you did. Now we started out. Whoops, sorry. Okay, so part 2 of the notes. Welcome, welcome, welcome. I'm Lisa Blackburn. This is my YouTube channel. All right, so we're going over, this is kilo, hecto, deca, basic, which is like grams, liters, meters. What's little d? Deci. Deci. All the E's go together. So what is C? Centi, like centimeter, and little m? It is milli, like millimeter. Now big M is mega. So it matters whether it's capital or not. But sometimes that's one of the things you'll see wrong. People will put a big D when they mean deci, and it's wrong. It's supposed to be little d. So. All right, so I showed you last time that how you do this is you frog hop. So if we wanted to change kilometers to millimeters, you start where kilometers is. Oh, I need to hit draw. You start where kilometers is, and you count how many hops it is over to where you want to go and in what direction. So this one's 1, 2, 3, 4, 5, 6 in this direction. So your decimal point will go 6 places in this direction. 1, 2, 3, 4, 5, 6. You augment zeros in each of those hops and you get the number. So it's 4, 8, 1, 2, 3, 4, 5, 6, 7, 8. Do you see how that's easier than doing the dimensional analysis? It's easier than setting up those railroad tracks. So if it's just converting from one metric to another, this is easier and faster. And I'm going to give you a worksheet tonight that you'll be doing that too. So we're going to change 6 liters to centiliters. I want you to try it by yourself, and then I'll show you how to do it. Try to change 6 liters to centiliters. We don't usually call it centiliters. Okay, you ready? So liters is a basic unit. We start here and we go to cent, which is 2 frog hops this way. So we go 2 that way, we augment zeros, and it's 600 centiliters. Did you get it? Yeah. Does anybody not understand? Okay, let's do another one. Let's change this number of milligrams to decagrams. Everybody try it by yourself first, and then we'll do it together. Okay, you ready? Yeah, we're going from milli to deca. That's 4 frog hops this way. So we're going to take our decimal point and go 4 places this way. 1, 2, 3, 4. It's 67.9 decagrams. Did you get it? Great. Okay, our next idea is density. Oh, and I meant to bring something to show you, but I didn't. I was in class last night till 7 o'clock. Just had to leave right after school. Didn't have my thinking time of what I needed to do. All right, so density is our first equation we're going to learn. And density is mass over volume. Did y'all already know that from physical science, from something like that? Density is what is called a physical property. We're going to learn more about this, but things have physical properties and chemical properties. So a physical property would be like color, things like that. Things that are just a property of the substance. Hardness, things like that. And then chemical properties are how they react with other elements. So a chemical property would be, does it burn with oxygen? Okay, but this is a physical property. It's something that is fixed for each element. And how you get it is mass divided by volume. Now, notice how I wrote the division bar as a slash here. You are not allowed to do that if it's numbers. And also, so if you have 1/2, I want flat fraction bars. Now, why in the world? I don't want you to do that as 1/2. I did it because typing, it doesn't like to do a fraction bar. It's too big of a pain. But I don't want you writing this. The reason why is I've taught for decades, and we're not going to talk about how many. And kids write messy, and they forget what they've written, and that turns into 112, and then they miss it because they didn't write neat enough. So I want you to always use flat fraction bars with numbers, with units. If it's like grams per milliliter, you can do the slash if you want to, and the per slash. Any questions about that? Okay, so I'm picky about certain things, but it's only for you, for your success. All right, so this is how you do a word problem. This is the exact thing you pretty much learned in math class too. But this is how we're going to do problems in science. So first of all, here's our question. First of all, what makes a word problem hard? What makes a word problem hard? It's the words, the fluff around it. It's not the math. The math is easy once you know what to do and get rid of all those words in the way. So when we do a word problem, what we want to get rid of is the words. Everybody agrees to that? Okay, so we're going to read this. What is the density? We're going to stop right there. As you read a word problem, this is what you'll be doing in physics also. So from now on in science, this is what you'll be doing. You need to identify your knowns and unknowns. That means the thing that has the question word for it, what is the density? That's your unknown. And I'm going to go ahead and put a question mark over that because I've already learned some information. What I'm looking for is density. Everybody good there? And then I go over here and I'll write density equals question mark. I make a list of my knowns and unknowns as I read the problem. Okay? Of a piece of lead, that could be important, not sure, so I'm going to circle it, that has a mass of 114 grams. So I've identified what mass is, so I'm going to write it over here. Mass equals 114 grams. I write the unit, the number and the unit, and a volume of 10 milliliters. So I'm going to identify that. Volume equals 10 milliliters. Okay, any questions so far? So identify your knowns and unknowns. Any questions? Okay, and remember I told you yesterday that I want to teach you how to play the game. And part of the playing the game is always guessing. Well, this is where I'm going to give you your half credit. For if you identify some knowns and unknowns, even if you get the answer wrong, I'm going to give you some credit. If you give me a blank, there's no credit I can give you. I can't make up some credit out of a blank. But if you show me, if you identify your knowns and unknowns and think of a formula and, do a little work, make something up, then I can give you some partial credit. Does that make sense? I can give you some, and it's not just me. Your college teachers do this too. I count, and if you have all right answers and no work, you only get half credit too. Because you might not realize this, but some students cheat. I know it's shocking, hard to believe, but it's true. So if I see all the right answers, but you don't have work to support it, how do I know you didn't get it sneak peeking or with your phone peeking on like that? You see? But if you've got work, then I believe you really did it. And college teachers do this too. And this guy came up to me, I was tutoring his son, and he was saying, I went to West Georgia, and I had the meanest teacher ever. It was a physics teacher, and I had figured out how to do all the work in my head, and I had all the right answers, and they gave me a 50 because I didn't show work. And I said, I do that too. And he was like, oh, you're mean too. But it's college too. You've got to prove what you did. Also, I have to be able to see what you did so that if you did it wrong, I can see what you were thinking. I could write on there and correct it. Because the point of a test is to learn also. And I want you to learn even through testing. So if you do something wrong and I see your work, I can correct your thinking. I can write on there so you go, oh, now I get it. And then you'll get it right on the final. Does that make sense? Everybody understand that? All right. So next you think of a formula, and our formula is density equals mass over volume. If you are writing a formula, I want you to write it on every single problem, not just at the top of the page saying C top of page. Why? Why would I make you write it every time? So you memorize it. Now, physics does something different, but I'm real passionate about this because I am a nerd, 100% science nerd. I think you should always use the formula in one form. So density is mass over volume. I firmly believe to never rearrange it for mass or volume. I believe you use it this way, then you substitute, then you do the math. The reason why is it will help you memorize it. If I rearrange it for mass or volume, one formula has become 3, and I'm less likely to memorize it. I know math formulas, I know chemistry formulas, I know physics formulas, there's even some formulas in biology, and I know them all. And it's very convenient for me to have memorized hundreds of formulas. If they all were, if I moved them around, I would never have learned them. So I encourage you to never rearrange formulas. Now, I told that to Mr. Myrick, who also teaches physics, and he said, oh, we make them rearrange them. And I said, they shouldn't. He said, well, if they could explain to me why they shouldn't, I'd let them not. So when you get to physics, you got to explain to Miss Raymond and Mr. Myrick why you should not rearrange your formula. You should, because it'll help you memorize them. All right? So next I have sing. Now there's a song. It's from before my time and before your time, and it's Substitute by The Who in the 60s. It goes like this. Substitute. Now, so at this point, I always sing the song, Substitute, because it reminds me that that's what I'm going to do now. Now, why do we sing little songs? Why do we do little dances? Why do I do hand motions? All to help you remember. So there are certain songs I always sing when I do certain things. Now, this made me think about you. When I was in 8th grade, I had a severe concussion. I had a horse, and I was in a horse accident where I had a severe concussion. Nowadays, they would have sent me home for a year and told me not to think. But back then, back in the 70s, the dark ages, they just sent me back to school. I saw double for, I think, 3 months. And not just a little double, like there would be a person here and a person just like you right there. And I had a concussion, and I never could remember what was the real one and what was the fake one. So there'd be 2 glasses sitting right there, and I'd be like, okay, I'm going to pour the milk. Which one is real? And I would always pick the wrong one and just be pouring milk on the table. And it'd be like, and my mom would be like, why don't you ask for help? And I'm like, because I want to do it myself. But it was so hard watching TV with 2 TVs sitting there. And so what I'd do is I'd turn all the way and cut my eyes where I could only see one TV. But anyway, because I was always in gifted ed, I was always in honors until the concussion. And when the concussion hit, and I'm still in these honors classes, that I was having to make up ways to help me learn and remember. So ever since 8th and 9th grade, the year of the terrible concussion, I have always sung these songs and stuff like that, and it helps me remember. And the great thing is it's really helped me be a better teacher, because I can explain things and I can give you ways to help remember things too. And we talked about geometry class. Did we talk about that yesterday? No. If I'm teaching geometry and I'm teaching you proofs and I want you to remember reflexive property, I'll hold out my hand because it's a mirror, and then I say, what property is it? And then you go, oh, reflexive property. Or what property is it? And this means transitive. If A equals B and B equals C, then A equals C. Remember those properties? What do you think this one is? Y'all have had geometry. Symmetric, the symmetric property. Remember that one? You're like, no, I'm trying to forget geometry. Geometry is great. All right. So one of the things is I have certain songs we sing at certain times, and this is the time we sing Substitute. There's one when I teach algebra where you combine terms, but I do a song called Gathering Up the Terms, and it has a dance too. And it's so funny because and it's from before my time too. It's all these 60s songs for some reason I picked. But I've had kids come back to me and say, Miss Blackburn, they were playing the Gathering Up the Terms song in Kroger. I'm like, yeah, but that's not what it really is. All right, so now we're going to substitute our numbers in. So right underneath, density is our unknown, so we're going to write D. Right underneath M, we're going to write the mass, and right underneath the volume, we're going to write the volume. Okay, so that's what I mean by substitute. Here's another thing. When you do math, I want you to work down, not out. Don't write it out here. Equals like that. Work down, not out. One reason why is when you do math, I want this area left blank for me as the teacher to write what you did wrong. So you have to leave room for me. So I want you to always work down, not out. And I want you to do that in your math classes too. I know I'm bossy telling you what to do in math, but it's what they expect in college. So let's go ahead and get trained for college, okay? So get in the habit of leaving some blank over here. Don't do 2-column your math. Go one problem after another, going down, turn the page over. It wastes a little bit of paper, but that's okay. Paper's cheap and your education is worth it. Okay, so now we're going to do the math. 114 divided by 10, that one's pretty easy, isn't it? So density equals 11.4 grams per milliliter. And the last thing I want you to do is box your answer. Now, check your units. Is grams per milliliter the right unit for density? Well, y'all don't know it, but it is. So that means I probably did the math right. If I was doing a speed problem, and instead of getting miles per hour, I got seconds squared times, something else, it wouldn't be the right units. I would know I did the speed problem wrong. And that is, so checking your units, we have fancy science nerd talk. It's called dimensional analysis. Fancy science nerd talk for checking your units and make sure they make sense is called dimensional analysis. Okay, and the last thing I want you to do is box your answer. Why do I have you do that?
So it pops out to you.
So it pops out to me and I can grade faster, but even beyond that is some children are bad and try to cheat. And one way they will do it is they'll do the problem every possible way. They'll divide 114 by 10, they'll multiply them, they'll divide 10 by 114, and they just put it all over the paper, and then they'll say, see, I got the right answer there. And you got to decide, is this your final answer? Like, Who Wants to Be a Millionaire? Anybody ever seen that old show? Is this your final answer? You have to decide on one answer and box it, and not just do the problem every way possible. All right, everybody good about this? Okay, this isn't too bad, is it? Okay, next, our last idea. Measuring moles. Now, a mole is a cute little animal that will dig up your yard. I grew up in the city in Smyrna, which is really close to Atlanta. It never gets dark there. I'd never really seen stars till I went to college. Lots of pollution all the time, and no moles. Had never seen a mole till moving to Paulding County. But now I've seen them. And they're not quite as cute as I thought they were. Has anybody ever seen a mole? Like, say your cat will kill one and bring it to you as a love offering, lay it at your door. Yeah, that's how I've seen it. So my husband was feeding some outdoor cats, and they would love him by bringing him little dead moles. But anyway, so color your mole, but that's not the kind of moles we're talking about. So moles is how we measure things in chemistry. So when you go buy eggs at the grocery store, what do you buy them in? What unit do you buy them in? A dozen, right? So we have a word, dozen. And how many is a dozen? 12. So this word, dozen, has a numerical meaning 12, right? What do you buy socks in? Pairs. And what is the number that goes with pair? 2. And there is also another word for pair. What is for pair or two? What is it? A couple. Couple. Now, why do I say all of this? Is how you get chemicals. Chemicals, you get chemicals in moles. Mole is what it's called that you go get chemicals in. It's the unit we use to measure chemicals. And it also has 3 names like 2, okay? A mole is also called Avogadro's number, the guy who invented it, and it is equal to 6.02 times 10 to the 23rd power. It's actually 6.022, but since it's just high school, we leave off at 2. But in college, you might get to have that extra 2 back again. But it's how we measure chemicals. So if I go to the stockroom to get chemicals for a lab, I'm going to get a certain number of moles of that chemical. Just like if you go to the grocery store to get eggs, you're going to get a certain number of dozens of eggs. Does that make sense? Can you follow this? Okay. Now, who's the dude? That's Avogadro. Amadeus Avogadro. Italian fellow. Very interesting looking. You should look up what his real picture looks like. It looks pretty much exactly like your drawing. My drawing isn't very good, but your drawing's good, and it's what he looked like. And so he called it the mole, but everybody's so happy with his invention, they also call it Avogadro's number in honor of him. Like, he could have just named it from the beginning. It's my number, I thought of it, Avogadro's number. But instead, he called it the mole, but then they honor him by calling it Avogadro's number anyway. And that's why it's got two names. So a mole is a mole of a chemical. How much is it? It's its mass in grams, and that is called the molar mass, or MM is how we shorten it. You know, we have to do things the shorter way on the periodic table. So look at your periodic table. I made you get them out. Let me get mine back out again. Okay. So everybody take a look at your periodic table. Look at hydrogen. Everybody looking at number 1, hydrogen. H is its symbol. Its name is hydrogen. 1 is its number of protons. Atoms are made out of protons, neutrons, and electrons, and 1 is its number of protons. But there's a decimal number on there. Do you see how each one has a decimal number? Do you see that? That is its mass. It's its average atomic mass. We're going to learn a lot more about that. But for now, you can know mass is like weight. It's how much it weighs. And the unit is AMUs, atomic mass units. But this is the brilliance of Avogadro. He figured out that if you have that weight in grams, you have about 6.02 times 10 to the 23rd atoms. And that's a mole. Just like 12 eggs is a dozen, that many atoms is a mole, and it's a convenient amount to measure atoms in. So it's about a handful. And that's really convenient. So like if I have to do chemical recipe, it's not written in cups, it's not written in teaspoons, it's written in moles. I can look up on the periodic table. Say I want a mole, my recipe calls for a mole of carbon. Everybody go look at carbon, it's right there. Look at the decimal number, it rounds off to 12. If I go get 12 grams of carbon, I've got a mole of carbon. I go get my balance, I'll weigh out 12 grams, I've got my recipe amount. So kind of like England, you know, they cook using weights, they weigh everything. That's what we do in chemistry. We measure everything in either a liquid measurement in a graduated cylinder, or else we measure solid things by weighing them in grams. And how you know how many grams to get, the recipe, the chemical equation will call for a certain number of moles, and that's how. And then you look on your periodic table to see how much a mole weighs, and you go weigh out that many. Does that make a little bit of sense? Okay, so let's look at it on the board. Okay, so let's warm up. Y'all look at your periodic table and call out to me, what's the molar mass of nitrogen rounded off? 14. 14. You're brilliant. You're doing great. What's lithium? 7. Rounds off to 7. What about oxygen?
16.
16. Hydrogen? 1. Water? Ooh, I got tricky. Is water on the periodic table? No. Do y'all know the formula for water already?
H2O.
Y'all are so smart. H2O. So if you have something like water, then you have to look them up and add them up. So how do you do these problems? You write what you know. You write the units of what you know in the denominator. You think of a conversion factor. Let me show you. Oh, come on, thing. Let me show you what I mean. Whoop. Okay. But we're going to start with water first, okay? So I'm going to do it like this. Water is made out of hydrogens and oxygens, right? How many hydrogens are in water?
One.
Two. H2O. How many oxygens are in water? One. Now, do you see how I'm doing this vertically? I want you to do it vertically too. Now, what is the molar mass of hydrogen? 1, the M&M, okay? And you can color your M&Ms up there too. And what is the molar mass of oxygen? 16. So now I'm going to do this math problem. I'm going to multiply. What is 2 times 1?
2.
And what is 16 times 1?
16.
And now I'm going to add them together. What's 16 plus 2? 18. And the units is grams per mole. Grams per mole. Now, we're nerds. So the abbreviation for mole, M-O-L-E, is M-O-L. Whew, my hand is so much better off not writing that E. That would have tired it out. It's like sine. The abbreviation for sine in math is S-I-N. So it makes it look like you have a sin button on your calculator. Oh yeah, can't write that E. That just plumb tucker my hand out. Okay, so that's how you do it. Now, we're gonna do this problem. How many grams are in 4 moles of carbon? Let me find my thing here. I'm gonna roll that up. How many grams are in 4 moles of carbon? So this is how you do the problem. Write what you know. What you know is the number that you're given. So step 1, write what you
No.
know. And so we're gonna write 4 moles of carbon. We're gonna draw our railroad tracks. What goes in the denominator? Moles, right? We want this to be here. Moles of carbon. And then we want to change it to grams of carbon. So our conversion factor is the molar mass off the periodic table. What is the molar mass of carbon? 12. So there's 12 grams in 1 mole. That's the conversion factor. Does that make sense? 12 grams are in 1 mole. We want to know how many grams are in 4 moles. Moles cancel out. 4 times 12 is 48. So it's 48 grams. Put a box around it. What do you think? That is your first unit of chemistry. All right, not terrible. A little bit of math, a little bit of singing, a little bit of dancing. Not terrible. All right, I'm going to end the video. See you later. Science is great.